So again, I emphasize this is a SKEL4663. Okay, make sure that the course code is correct. Okay, if you are under the SEEL program, okay, so you need to change to SEEL 4663. Okay, so this is an embedded computer system course. Okay, my name is Dr. Muhammad Azlan, and this is for the section 1. Okay, so without further ado, let's look at the introduction to embedded computer system. Okay, which is this is our what we call here chapter 1. Okay, so this is the objective, okay, of the chapters 1. Okay, I assume that all of you already download the lecture notes from the e-learning. Okay, so it's quite similar to what I have here. Okay, so the objective of this course here, at the end of this module, okay, you should able to define what is the embedded system. Okay, next, you are able to differentiate between the embedded system and general purpose system. Okay, there are two different things. Okay, embedded systems and general purpose system. So you need to able to classify lah. Okay, this device is belong to general purpose system or embedded system. And at last but not least, you're able to define what is a system on chip, or sometimes we call it as a SoC. Okay, so let's look at the introduction to computing. Okay, so the development of the microprocessor has led to growth of a various computing device. Okay, because there are a lot of microprocessors out there. Okay, some of the microprocessors that you already know is such as the Arduino. Okay, then we have ARM processors. Another one we have the Qualcomm's, and then we have the AVR processors. So this has led to growth of various computing devices. Okay, so there are typical computing devices are such as, okay, we have your phones, tablets, laptops, desktop, and servers. So all of these computing devices have a processor inside it. Okay, either it's a user an Intel processor, AMD processor, Snapdragon processor, or Qualcomm processor. Okay, depending on the manufacturer, which processor that they're going to use. Okay, and there is a different class of computing device, okay, which is known as embedded computers. Okay, which is it's quite different compared to this computing device that we already know. Okay, that one we call it is as a embedded computers. Okay, one of your embedded computer, the easy example of an embedded computer that you can find near you is your calculators, okay, your smartwatch, and then you have your refrigerators, your printers, and etc. So this is, we call it as a embedded computers or embedded systems. Okay, now we are going to look at what is the embedded systems. Okay, so the embedded system are computer with a constraint. Okay, so this embedded system has a constraint. Okay, compared to the general purpose computer. Okay, this embedded system is designed for one target application or dedicated function. Okay, it can have at least one application ataupun can have several application, but or several function, but not similar to the general purpose computer, because the general purpose computer, it can have many applications. Okay, you can reprogram what application that you're going to use, then you install that application, then you can use that application to your computers. But the embedded system, you cannot reprogram. Okay, if the embedded system that you buy have a 3 function, then it is only can do that 3 function only. Okay, cannot install another function to that embedded system. Okay, there are more embedded systems in the market than personal computers. Okay, so nowadays, okay, we have a lot of embedded system inside of our house. Okay, for example, okay, inside of our house, okay, maybe you have a 5 family members. Okay, Okay, your general purpose computer might be have 5. Okay, ada 5 saja. Okay, but inside of your house you have many embedded system. Okay, starting from your kitchen, which is you have your microwaves, you have your refrigerators, you have your coways. Lepas tu kamu ada cuckoos for the water filtration, and then apa lagi? You have the rice cookers and all those things. Air fryers, itu baru dekat kitchen. Okay, and moving on to your living house, you have your televisions, routers, and etc. Okay, or maybe you have a smart what we call here smart switch. Okay, set that one is also another embedded system. Okay, to control your switches. Either you're going to switch turn on your fans. Okay, and then you have the air conditioners. Okay, that one is another embedded system. So the embedded system market is a $1 billion business. Why? Because there are a lot of embedded system around us. Okay, so that's why the system is quite bigger. Okay, and billion of units produced yearly versus million of desktop units. Okay, because why? Because one person only have to have one PC. Okay, and paling banyak pun 2 PCs, one for the laptop and one for the desktop. But embedded system, one person might have 20s or 30s embedded system around him. Okay, so that's why, okay, the number of units for the embedded system are way greater compared to your general purpose computers. Okay, so this is the figures, okay, for the general purpose PCs, and this is the figure for the embedded system. Kalau kamu tengok, okay, both share the same thing, which is this one have a processor, embedded system also have a processors, okay, and then it has the memories, okay. So yang ni memories dia dalam processors ni lah, okay, and then it have the outputs for display. Okay, so this is an output here. Okay, you can use the LCDs or you can use this here LEDs here as output, or this DC motor as your outputs, and then you have this thing here. Okay, the keyboard or your mouse as an input. Okay, for the embedded system, all these sensor here become your inputs or the switches here. Okay, so that is the difference between the general purpose PCs and embedded system. So now in the next few slides, okay, we are going to look at a lot of examples of embedded system. Okay, ada banyak embedded system yang kita nak tengok in the next few slides. Okay, so here, this is a sample of the application, okay, for the embedded system. Okay, let's look at this application here, okay, for the digital signage. Okay, so this digital signage, okay, it will display, okay, the public video will be displayed primarily for the advertising or entertainment. Okay, kalau kamu masuk UTM, okay, that is the digital signage. Okay, at the entrance of the UTM, kamu akan dapat dia punya billboard tu. Okay, it will display all the videos, advertising, what happens in the UTM now, all those things. Okay, so that one is one of the embedded system. And then we have the digital storage. Okay, so this is an application for digital storage, such as a network attached power and area efficient storage of enterprise, small business, and homes. Okay, then we have the factory automation. So all the management and control of manufacturing facility assets. So this will be done by the robotics system. Okay, the robotics things. Okay, and then gaming. Okay, for the gaming, you have your consoles. Okay, your video games. Okay, so that one is another embedded system. Okay, and then in the vehicle, okay, in vehicle there are a lot of embedded system inside of your cars actually. Okay, starting with the infotainment system, okay, your braking system, navigation system, okay, then you have safety system and all those things. Okay, later we will see more details on that part. Okay, and then we have the IP camera. Okay, another application for embedded system is IP cameras, IP media phones. Okay, for the medicals. Okay, so for the medical, you have the platform for the medical imaging and managing the patient records, or sometimes, okay, you have the all the device to what we call here, to measure your temperatures, okay, by using the digital temperature. So that one is another embedded system. Or you're going to measure your SpO2, okay, your oxygen saturation in your blood. Okay, that one also another embedded system. Okay, that that we commonly use now. Okay, during our pandemics. Okay, COVID-19 pandemics. Okay, and then we have the robotics, sensors, transportation, wireless processor, and infrastructure. Okay, so inside of this is an embedded sample of the embedded applications. Okay, now moving on to this slide here. Okay, so this is an embedded system in automotive. Okay, as I mentioned earlier, inside of one car, a single car, okay, you can have a lot of embedded system. Okay, start from the infotainment and telematics. Okay, which is you can have a hands-free. Okay, then for the navigation, okay, to navigate from one point to another point. Okay, either you're using the Waze, okay, so or the Garmin, okay, that installed inside your car. So that one is one of the embedded system because you have the GPS receiver inside of your cars, and then maybe you can do the calls, okay, DVD playbacks, radios, okay, so your radio also one of the embedded system, and storage device, which is you can put your thumb drive, okay, to play your songs from your thumb drive to your radios. Okay, and then we another one nowadays all of the cars coming with the adaptive lighting control, which is it will automatically turn on and turn off based on the during a day or during a night. Okay, then for the body electronics, okay, we have the power windows. Okay, by pressing a button, then your power will wind up or wind down. Okay, mirror controls. Okay, you can control your mirrors, side mirror by using the button inside of your cars. Okay, remote keyless entries, smart junction box, power lift gates. Okay, by press a button, okay, from your remote, okay, your lift gate will open. Okay, and the gateway modules. Okay, so and then this one is for the engine management. Okay, we have this embedded system here inside of the engine management, such as a diagnostic test and interface. Okay, if there is error come up, it detected inside of your engines, and then the error will appear on your dashboard. Okay, on your panels here on at the driver's panels. Okay, indicate that okay this error has come out, so you need to go to your nearest service center and check what is the error. Okay, because a light will come out and you know that okay, so your car has an error, so you need to repair it immediately. Okay, and then we have the instrument cluster, okay, which is such as a hardware architecture, HMI component, and all those things. So this is inside of the one car. There are a lot of embedded system has been integrated. Okay, in order for the safety of or for our infotainment, for our leisure, and etc. Okay, so this is another okay embedded system inside of what we call here our car. Okay, and now we go to the next slides. Okay, a part of the car. Okay, so we also have an embedded system in aeroplane. So this is another example where the embedded system is being used. Okay, one of them is inside of the aeroplane. Okay, there are at least 500 systems inside an aircraft. Okay, dalam satu aircraft at least 500 system. Okay, so the first one is coming from the wings. Okay, so to control the wings, there is an embedded system to control the wings and the jet engines. Okay, how to do autopilots, landing gears, brakes, and so on are controlled electronically from the cockpit. Okay, so all of this here, okay, will be controlled by using the embedded system. And then for the location, weather, altitude, the aircraft speed, orientation, all these values are constantly monitored. And these values here will be displayed on the passenger side as well as on the pilot side. Okay, if you go to your what we call here, uh, your seat, okay, there is a display there on the monitor. Okay, you can click your monitor and check what is the weather, okay, what are the current altitude, what is your speed of your aircraft, and what is the distance, okay, remaining distance, okay, to your destinations, and the estimated time arrival. Okay, all of this here are used and embedded under an embedded system. Okay, so the attribute of the embedded system for the aeroplane, it must have this reliability. Okay, why? Because, okay, this aeroplane is crucial lah because kita kat atas. Okay, so in order to make sure that the aircraft is in a top condition, okay, so all of the embedded system must works accordingly. Okay, if there is one problem or one issue found, then the aeroplane might not take off. Okay, dia tak akan terbang. Okay, so all of these embedded system, all of these system inside of this aircraft must be works 100%, and then after that the aircraft can be take off. Okay, then the security. Okay, kenapa security? Because another attribute is security. Okay, this is to avoid from any hijacking or any hacking to control this aircraft from bawah or from other sides. Okay, so that's why to need to make sure that the security is strength lah. Okay, your embedded system has these securities for these aeroplanes, and it is real-time behaviors. Okay, so aeroplane must have a real-time behavior. Okay, means that all the signals must be in your real time, cannot have a delays. Okay, for example, okay, your location, okay, your location cannot have a delay, or the altitude cannot have the delay, because this altitude, this location will be sent out to the aircraft controller ataupun dekat you punya airport, okay, in order to arrange the traffic, okay, from one aircraft to another aircraft, so that there is no collision between aircraft in the air. Okay, so that's why it must be have a real time behavior. Okay, next we go to next slide. Okay, which is the Internet of Things. Okay, now we always heard of word IoT, Internet of Things. Okay, everywhere we go, people will talk about IoT. Okay, so let's say if you go to the medical fields, okay, they will talk about, okay, why not we use this device and connect it to IoT, so that the doctors, okay, can what we call here, can diagnose or can check the patient remotely from the hospital. Okay, so the IoT is a big thing lah nowadays. Okay, so now we are going to look at what is IoT and why IoT become a trend recently. Okay, so the IoT, the Internet of Things, will focus more on the distributed nature of the hardware and the communication between nodes. Okay, so the attribute of the IoT as follow. Okay, which is a node are everywhere. Okay, we have a lot of nodes. Okay, around the world. Okay, this is by using the communication protocol or either a securities. Okay, and then this IoT, okay, might have an energy efficiency. Okay, so that it can work longer. Okay, and most of our IoTs now have this machine learning in order to do a big data analytics. So these are the attributes that need to have in the IoTs. Okay, so before we go more details on the IoT, okay, let's look at the four industrial revolution, okay, or famously known as a IR 4.0. Okay, the first revolution is where the mechanization is started. Okay, this is led by the steam engine. All of the works, okay, heavy works started with these mechanizations, and then after that, after we have the what we call here, mechanization system. So next, what happened is we can come up with a mass production, okay, because all of the production have been done by this machine, okay. Because of this machine was introduced, okay, then the production is increases, okay, compared to if you're going to do it manually by using people or labor, okay. So this mass production is a second revolution, which is driven by the electricity and oil-based power. Okay, so all of these machines here now previously use a steam engine. Okay, now it use the electricity or oil to power up these machines, and due to that, okay, a lot of production have been increases. Okay, and then for the third revolution, we have the automated production. Okay, which is this automated production is done by the robotics. Okay, by the robots. Okay, so this is supported by electronics and information technologies. So this is in 1969, and today, okay, so a lot of new technologies come out, such as the IoT, artificial intelligence, big data, okay, cloud storage, cyber physical systems, and then you have the uh, machine learning, okay, deep learning, etc. Okay, so now we are in this 4.0 revolutions. Okay, so this is the how the industry revolution from first revolution until today's revolution. And due to the internet of things, okay, you can see here, okay, the device or the device produce increasingly, okay, from 1 million to 50.1 billion in 2020 alone. Okay, sekarang lagi tinggi lah, lagi banyak device yang kita ada in the markets. Okay, which is inside of this device, okay, this IoT device is controlled by the embedded systems. Okay, so we have a lot of embedded system nowadays, okay, in our life. So this is the relationship between the IoT with the embedded system. Okay, you can see here. So this is the one embedded system. Inside this embedded system, it has the processor. Okay, and this is an IoT device, and this is IoT gateway. Okay, inside of the processor, you have the IoT device, which is to transmit data to IoT gateway, and from this, the gateway here will be transmitted to a network, okay, and to the internet throughout your cloud, and after that, you can access it anywhere, anytime you want. So this is the relationship between the IoT and embedded system. So it means that inside of the IoT, there is an embedded system dalamnya dia. Okay, so the Internet of Things or IoT is referred to a system of interrelated internet connected objects that are able to collect and transfer data over a wireless network without human intervention. Okay, so previously, without using IoT, okay, to switch your aircon at your home, okay, you need to go to your home, okay, and then press the switch. Okay, now what happened here is by using your smartphone, okay, you can control your aircon, okay, switch your aircon, and then after you reach your home and your house already cool down. Okay, so this is what the IoT is about. And this IoT is made of embedded device. Means that all of the IoT have at least one embedded system inside it. Okay, so I think I stop it here. Any question? Ada soalan tak?